We're at go2math.com. Let's click on the calculus and go down to concavity and the second derivative test. We're going to be doing 2-1. Look at that. First one to come up. It says find the concavity of the graph. So in the first problem set, we kind of talked about that already. But so that ought to be pretty easy for you to figure out here. Well, let's write this down and then go over to the whiteboard and figure it out. As you can see, this red dot right here actually indicates where the inflection point is located, and of course we need to know that to determine the actual concavity of the graph. So we had f of x is equal to 2 times x minus 4, and I believe that was raised to the third power plus 2. So to find the concavity, of course we've already found the concavity in the first problem set, but we are kind of doing it officially now. So take the first derivative, that's going to be a 6x minus 4 squared. Derivative of the inside, bring it out, but it's just 1. Derivative of 2 is 0. Okay, so now we do the second derivative, and we end up with 12 times x minus 4. And then what we'll do is set this equal to 0 and find the solution set. And of course, as you can see, x is equal to 4 here to make this 0. Alright, and then what we're going to do is once again do a number line. So we found the inflection point. This was pretty much the same thing. Let's get a test point. 0 is always good, and 5. Test point. Now we want to take this test point and plug it into the second derivative. Alright, so f double prime of 0, and all we care about is if it's negative or positive. So we plug 0 in, we get 12 times the negative number, so we know that's negative. Right, negative. So this is going to be concave down from negative infinity up to 4. And then we do f double prime, plugging in 5, our other test point, into the derivative, and 5 minus 4 is 1, and 1 times 12 is 12, so that's a positive number. And that's all we really care about. Okay, so that's going to be concave up. So negative is concave down, positive is concave up. Alright, so we could say concave, I'll just label it to CD. Concave down is from negative infinity to 4. And notice that we're using an open interval. And then concave up, we'll just say CU. And that's from 4 to infinity. Alright, so we use the parentheses here because we can't include 4. We don't include 4. It's not concave up or down at 4. Okay, so there it is, negative infinity to 4 and 4 to infinity. And of course, remember the inflection point. It's occurring at 4 f of 4. Right. Alright, well, let's go back and take a look at this graph. So we said 4, right? 1, 2, 3, 4. So as you can see here, so this is going to be the concave down, right, and then concave up. So we say concave up holds water. Right? It could hold some water in there, maybe probably run down that way, but I don't know. That's what we say. All right, and let's see what the script says. Hopefully it agrees. Yeah, negative infinity to 4, concave down, and concave up 4 to infinity. So that's not too bad. Not too bad at all. Alright. So come on over to Go2Math, practice that, and maybe you'll chat with me there. Alright, bye.